Okay, so today we will start with the remaining part of unit number first. Okay, so up till now we have completed about the fundamental steps in image processing, then fundamental components in image processing, every basic definitions, representations, right? What do you mean by resolutions? How to calculate the size of the image. So all that part we have discussed. Okay, now we are going to discuss about the types of digital image. So all of you know, based on that b value, actually we are going to decide the type of image, right? And what is that b value? That number of bits used to represent a single pixel, right? If you're able to recall the definition, you can easily understood this thing. Okay, what is the formula to calculate the size of the image? It's a m into n into b. That b is nothing but, or you can represent it as a k. No, it doesn't matter. You can use any letter. Okay, any alphabet you can use, but normally k or b is preferred. So m into n into b. So that b is number of bits used to represent a single pixel. Now, based on that, we can have the three different types of images. If you have used b as a 1, that means number of used to represent a single pixel for with only 1 bit. So 2 raised to 1 will be 2. That means how many gray level will associate with that particular pixel? Only 2. Only 2 gray levels. That means either a black or white. Black will be represented by 0, white will be represented by 1, and that type of image is called as black and white image. It has only 2 gray levels and b is equal to 1. Next, if you choose that b is greater than 1, or you say if you say you choose that b as a 3 or anything greater than 1, okay, that means you have used 3 bits to represent that particular pixel. Now 2 raised to 3 will be 8. That means how many gray level it will associated with? 8 gray levels. If you choose that b is equal to 8, right? If you choose that b is equal to 8, then what you will get? 2 raised to 8 will be 256. That means for a single pixel, you are using 8 bits to represent that pixel, and you will get the 256 gray levels, right? That each pixel is given a gray level value between 0 to 255. That means total 256, right? So in that case, 0 will be black, and that maximum value, that means 255, will be a white. That means 1. Okay, in that way we are actually deciding which type of image it is. Similarly, if you choose that particular b, okay, as a 24, that means you have used 24 bits to represent a single pixel, then that can be known as color image or RGB image. That means 8 for red, 8 for green, 8 for blue. That image is known as RGB image. If you choose b is equal to 24, 2 raised to 24, that many gray levels, right? And that for each color again, that is for each color, you will get that different level. That means 256 level for red color, 0 to 255 levels for green color, and 0 to 255 levels for blue color, right? These many colors you will get if you choose b is a 24, and that type of image is known as color image. That type of image is known as color image, right? Again, if you do some modification, instead of writing, okay, that entire RGB value, if you give some index to that value, for example, this, if you give an index 2, that means for this index 2, what is value of red, what is value of green, and what is value of B. So instead of mentioning this RGB value, you can index that, and you can mention the index value. You can mention the index value, and that type of image is known as indexed color image. It is color image only, but with some index, right? That type of value is known as indexed color image. Okay, so this is about the types of images. Now we will discuss about the basic relationship between the pixels. Now you have already this part also we have discussed. Okay, you have Euclidean distance, you have city blocks distance, that means D4 between any or you can say between two pixel, it's 4 neighborhood pixel, right? You have one center pixel and it's 4 neighborhood pixel. There you can define the city blocks distance. Then for neighborhood as well as diagonal pixels, you have a chessboard distance, that means D8. That means what is relation between that center pixel and its every surrounding pixel. You can easily calculate with the help of basic distance measurement, right? You have Euclidean distance, and all of you know the formula how to calculate Euclidean distance, how to calculate the D4 distance, or it can be known as city blocks distance, and how to calculate D8 distance, or it can be known as chessboard distance. Okay, so this is what city blocks distance, chessboard distance, and it is a 6 connected. Okay, if your cell is of pentagonal type, then or your area, if your area of image is will be of pentagonal type or hexagonal type, then you have 6 connected. Okay, this is how we are calculating the 4 neighbors. D8, that means 8 neighbors, along with diagonal elements. You have 4 up, above, left, right, these 4 elements too. This is the same thing we have explained here. This is the image, and these are the D4, or you can say city block pixels, and you have again D8, that is chessboard distance. So already adjacency, 4 adjacency, 8 adjacency, then what is connectivity, path between two pixels. Okay, now region, what do you mean by region, what do you mean by boundary? Okay, and always remember, we have studied this thing. Age is nothing but the high frequency part in an image. Okay, whatever the edges, boundaries are represented in image, that are always high frequency components. Okay, and for that we need a high pass filter. Now we have discussed this example also, right? How to calculate the shortest distance between any two pixels. So you have a source pixel, you have a destination pixel, right? And there you have to find the shortest 4 path, shortest 8 path, and shortest m path between any two pixel. Okay, and for that you can consider the range, that is 1 and 2, that is the value in your numerical itself they will provide you, and then you have to analyze it, and then you have to calculate the distance. For example, here we will calculate. So first we have to check the 4 adjacency, or 4 connectivity. Then we will first travel by 2, then to this one, not this 2. Why? Because from this we cannot go further, because we have to choose only 1 or 2 value. Here is 3, so we cannot go to the 3 value. So we cannot choose this above element, we have to choose this right element. So we will go to this. Then after, where you will go, you have above option and you have right hand option. Above option is 3, you cannot choose 3, then you have to go to the 2 only. Okay, then this after 2 you can have right hand side 3, so that cannot be, that should not be considered. And you have above 2, so we will go above 2, because we have to choose either 1 or 2 value. Then again same thing, Here you have right hand side also 2 and above is 1. Both values are valid, but where to go? If you go by 2, if you go by selecting 2, then you will stuck there. You cannot move further because it's below is 3 and above is 3. त्याच्या डोक्यावर 3 आहे, खाली 3 आहे. तुम्ही नाही जाऊ शकत. आपल्याला 1 किंवा 2च व्हॅल्यू सिलेक्ट करायच्या आहेत. मग तुम्ही कुठली सिलेक्ट करणार? यू विल सिलेक्ट द 1. And now again, where you will go? Because we are choosing the 4 connectivity, so there we stuck, because in 4 connectivity diagonal elements we cannot consider, only up, above, left, right, वरचे खालचे डावीकडचा उजवीकडचा एवढे 4 कनेक्टिव्हिटी मध्ये हे 4च पिक्सेल. 8 कनेक्टिव्हिटी मध्ये तुम्ही सगळे करू शकता, डायगोनली ऍज वेल ऍज अप, अबाव, लेफ्ट, राईट. त्यामुळे 4 connectivity is not exist. Now we will check for 8 connectivity. Yes, we can go for 8 connectivity. So first we will travel to the 1, then we will travel to the 2 because it's still diagonally connected. Okay, then we will travel to the 1 and finally we will travel to the 2 that is diagonally connected. That means 8 connectivities exist but 4 connectivities not exist, right? And then again you have to calculate the shortest path. Clear? So this is about unit number 1st that we have studied. Okay, and we have revised also. So if you have any doubt regarding this unit, you can ask me right now, otherwise we will stop here.